All right, so look at example 5 here. It tells us to solve, so what are we going to do?
Move the 1 over.
Move the 1 over. So 4 sine squared of x equals 1.
Square root both sides.
Not yet.
You can.
Move the 4 over.
It would be 2 sine of x equals.
You could, but we're not going to. Sometimes it doesn't work out nice and pretty like that, though, okay? All right, so we got sine squared of x equals 1/4. Then what can we do?
Wouldn't it be positive and a negative?
So when you take the square root, we're going to get sine of x equals, good, she pointed out, it's going to be plus or minus. And remember, when you take the square root of the fraction, it's the square root of the top over the square root of the bottom. Guys, don't automatically start trying to get the square root off the bottom. I saw that on some previous work y'all did. What's the square root of 4? 2. So you don't have to work to get it off the bottom, okay? So we have sine of x equals plus or minus, what's the square root of 1?
1.
And you already told me the square root of 4 is 2. So I'm looking for where sine of x is either positive or negative 1/2. Well, what quadrant says sine positive 1/2?
1 and 2.
And where is it going to be a negative? 3 and 4, right? So I have 4 answers because I need one from each quadrant. All right, so x, my angle, is equal to, what is sine, x or y?
Y.
So where is y in the first quadrant, either a positive or negative 1/2?
It's pi over 6.
And what about the second quadrant? And the third quadrant?
7 pi over 6.
And the fourth quadrant.
11 pi over 6.
And so there's our 4 solutions. All right, so on example 6, 3 tangent squared of x minus 1 equals 0. Same idea, we got to get the trig function by itself. So let's move the 1 over. So 3 tangent squared of x equals 1. Divide by the 3. So tangent squared of x is equal to 1/3.
So then it would be positive and negative.
Take the square root, so we get tangent of x equals plus or minus, what's the square root of 1? Over, what's the square root of 3? Square root of 3, right? We can't actually take it. Don't start trying to get that off the bottom, because what do we know about tangent, though, in terms of x, y, and r?
Can't you have the bottom?
It's y over x. So that's okay. This isn't our final answer. It's okay to leave the radical there right now.
How do you know it's y over x? What are you talking about?
Because it's tangent.
I know, but what are you putting y over x over there for? We didn't even get an x or y.
No. It's because, like, we know the sine is y and we know cosine is x. We know tangent is y over x.
Okay.
Okay? So, now, where is tangent going to be positive at?
And 1 and 4.
1 and 3. And where is it negative at? 2 and 4. So, again, anytime you notice you have plus or minus, you're going to have 4 answers, 1 for each quadrant. So, let's find our angle then. Now, remember, when I look at this, we said tangent is y over x. So, when I'm looking at my ordered pairs, that means my y is going to have a 1, my x is going to have square root of 3. Now, granted, we know they can be plus or minus, right? But remember, tangent special. We said we could put x and y both over what? With tangent? Over 2. And that's because when we do our keep it, change it, flip it, our 2's will cancel out. So, look in quadrant 1 and tell me which one has an x value of square root of 3 over 2 and a y value of 1/2. Pi over 6. Alright. Okay, so then in quadrant 2, now this time, because we're in quadrant 2, we know our x is going to be negative. And so we're looking for the negative square root of 3 over 2, comma 1/2. And that's going to be at 5 pi over 6. Quadrant 3, we know x and y are both negative, so it's going to be at 7 pi over 6. And in quadrant 4, our y value is going to be negative, which is 11 pi over 6. And so there are our 4 solutions.